we're going to talk about open sentences today, or absolute value inequalities. At any time that you need to pause the video to work or to check yourself, please do. These should be copied into your spiral. Anything that I have on the video, you need to have. So let's talk first about what absolute value is. We know that absolute value is the distance from any point to zero, and absolute value is always positive. So these are just some equations, has an equal sign. So if we think about x is equal to 5, we know that we could put in something into that value, and we could have 5 because it's going to come out positive, but we can also have negative 5. So we have two values there. Now, if we have a negative 5 and it has to come out as a negative 5, we ask ourselves, is this possible? Is there anything that I can put in to this absolute value here and it's going to come out as a negative 5? And if we remember what absolute value is, it does not come out as negative ever. So this is actually a no solution. Absolute value can never equal a negative number. That is very important to know. So if you need to write that down, please do. Absolute value can never equal a negative number. So now let's move that into inequality concept. So the thing that you're going to need to know here is with inequalities, when you have a less than or greater than sign, and it could be equal to as well, there's a little way to help you remember what type of inequality it is. So these are going to be compound inequalities, but we need to know what type of compound inequalities. Are they and or ors? So there's a way to help you. So when you read it from absolute value alone, when it's all by itself, and we'll talk about doing that, and we're going to read the sign the way it's written. So the absolute value of x is less than 5. So less than is an and statement. So when you say less than, it's an and you're always reading from left to right, absolute value first. So if it's written backwards, like 5 is greater than absolute value of x, we would still read it from our absolute value to what it's equaling or what it's comparison to. So you can rewrite it in this form so that your mind doesn't play tricks on you and you can read it left to right. So the same thing here. When we have an absolute value is greater than 5, think about how we speak sometimes Southern, greater, this is an or statement. So that's the first thing you have to really be aware of. So when you think about absolute value of x is less than 5, if we know it's an and statement, we know that we're going to have two situations set up. It could be a negative 5 or 5, and it has to meet both criteria. So if we were graphing this, we'd have a negative 5 and a 5. This would be open circles, and we think about and. So it has to be both of them. So it has to be less than 5 and also compared to negative 5. So this is in between. And we're going to talk more in detail of how to get that. Whereas greater, we're thinking about negative 5 and 5, open circles. This is where we're going on the outsides of those. Those are those or statements. So it's negative 5 or 5. So we'll get into more detail about that. So the first thing we're going to talk about is equations with absolute value. So you have to make sure that you get the absolute value alone. And because you're going to have two situations or two possible answers, you're going to have two equations. So we're going to start with equations to help you kind of move into the compound inequality concept of open sentences. But right now we have the absolute value of x plus 3 is equal to 5. So we could think about what could we put in there for x that would get us 5 when it came out. Well, we could guess and check, but that's not going to be very helpful when we get more complex. So we're actually going to set up two equations. The first one, we're going to pretend that these absolute values here are gone. So we're going to just pull it out. X plus 3 is equal to 5. And we're also going to set up another equation. This one, we're still going to know that the x plus 3, the absolute value is gone, but this time we're doing equals a negative 5. So we change this inequality sign, this sign from a positive to a negative in our second one. And we solve both of them. So minus 3 on both sides, we get x equals 2. Minus 3, x equals negative 8. So we have two answers. The way we would graph an equation, negative 8 and 2, this would be equal, so this would be a closed, and there would be no shading because we're not talking about inequalities. So we have two separate ones. So let's do another one. So B, we're first going to get the absolute value. We're going to pretend that it's gone. I'm just highlighting them just to help you remember. They're still there. We've got two. When you see them, we've got two equations to set up. We want to get the absolute value alone. It is alone, meaning there's no number out here, nothing being added to it or multiplied by it. So we're going to get it alone. So 4m minus 3 equals 7. And our other equation is going to be 4m minus 3 equals negative 7. So it's the opposite of what this was. Now we're going to solve. Plus 3, we get 10. 4m. Then we're going to divide by our coefficient of 4 on each side. And we get m equals 10/4, which we can simplify down to 5/2. This one, plus 3, we're going to have a 4, which is a negative, equals 4m. Divide by 4, we get m equals a negative 1. So if we had a graph, a negative 1, it's an equals, so we know here, we put a solid, and then 5/2 we can put down here. This would be what our answer would look like graphed. All right, I'm going to go to the next one. I want you to pause and try it. This is a star. Remember, our first thing, we have to get absolute value alone. So I want you to try it and then come back and see if you got it. All right, so you see here, I moved over the 9 first because I wanted the absolute value, this piece alone. So I had to get that 9 away because it was being subtracted. So I got absolute value of x equals 10. Then I set up my two equations, x equals 10 and x equals negative 10. That's my answer. So I could graph it if I need to. Negative 10, close circle, 10, close circle, and that's my graph. So remember, we're always going to get it alone first before we set up our two equations or inequalities we'll go to. So for this one, this is a 2-star. Go ahead and pause, come back and see if you got it. So on this one, before I set up my 2, I want to get the W, this alone, but I have 2 being subtracted and I also have a 3 being multiplied. So I want to add my 2 to both sides first, end up with 3 absolute value W equals 6. Then I want to divide by my coefficient. So I end up with the absolute value of W is equal to 2. Now I set up my two problems. W equals 2, W equals negative 2. Graph it, negative 2, 2, close circles, and I am done. So we have to make sure that we get it along. On E, it is a 4-star. Try this one and see how you do. All right, so some of you might have done this and you have gotten y equals 4/3 and y equals 4. However, that is incorrect. We do not have to do this because if we would look first and see, we see that whatever we put into here, so let's say we got 4 and we put it back in here. 3 times 4 gives us 12. 12 minus 8 gives us 4. But we have an equals negative 4. It can never equal negative 4. Remember, absolute value can never equal a negative number. So we can't do that at all. So this is a no solution. So if you did all that work, you did unnecessary work, pay attention that this is equaling a negative number. So we got to make sure once it's alone here and we look and say it's a negative number, we can't do it. All right, so we got a squiggly. We're going to go into inequalities now. And the first thing we're going to do first is figure out what type of inequality is it. So we want to get things alone, like we have our absolute value alone. And then we want to look and say, what type is it? So we always isolate first. This one's already isolated for us. So now we're going to read from left to right. The absolute value of 3 plus 2x is less than, so this is an and statement. This is an and statement. So we know we're going to have something that has to meet both criteria when we do an and statement. So now we're going to still set up the two criteria, or the two inequalities. There's a little bit difference with inequalities, and we'll talk about that. So we're going to take these out of absolute value signs. We're just going to pretend like they're not there for a moment. So 3 plus 2x is less than 11, and 3 plus 2x. And now because we have to make this 11 now a negative 11, we have to flip the sign. When we change it, we have to flip that sign on that second inequality. And now we solve it just like an inequality and then plot like an and statement, because remember we're doing an and. So minus 3, we get 2x keep our inequality sign. You can ignore it for now what it is. 8 divided by 2, divide by 2, x is less than 4. We know it's an and statement, so we'll bring down our and. We'll work the other side. Minus 3, minus 3. We end up with 2x is greater than a negative 14 divided by 2, divided by 2. We have x is greater than a negative 7. Now, these are an and statement. So when we go to graph, we need to have at least these on the line, negative 7 and 4. They're open circles right now. And let's think about what we do. X is less than 4, so this would be going this way. And x is greater than negative 7, that's going this way. And because it's an and statement, it's where they overlap. So it's this area here. So this is the area that would be graphed in. And make sure it actually works. So if we picked, let's say 1, 1's in here. If we picked 1 and plugged it back in, and we said 2 times 1 is 2, plus 3 is 5. The absolute value of 5 is 5. Is 5 less than 11? Yes. Now, if we pick something maybe up here that was like 7, and we tried it, 7 times 2 is 14, plus 3 would give us 17. The absolute value of 17 is 17. 17 is not less than 11. It doesn't work, so we know that we have it plotted right. And you could also check at the other end. All right, try B and see how you do. All right, so the first thing you want to do is make sure your absolute value is alone. It is. And so then we look at our sign. Less than or equal to, less than, and it's an and statement. So we set up our two equations or inequalities. In this case, 2m minus 5 is less than or equal to 9, and 2m minus 5, flip our sign, greater than or equal to a negative 9. Then we solve, graph it, and always check yourself. All right, so C, you should be getting the hang of this. However, there's a little bit difference here. So if we read this, 5 plus 2y, absolute value of, is greater or equal. This is an or statement. So we always want to make sure this is alone, meaning nothing's being added or multiplied or anything by it. And then we read it left to right. Great or is an or statement. Now we're going to set up our two inequalities. 5 plus 2y is greater or equal to 3. Or 5 plus 2y, flip our sign, and change it to a negative 3. Then we solve as normal. So pause here, solve it, and see how you do. So on this one, you would have got y is greater than or equal to negative 1, and y is less than or equal to negative 4. So put our 2 points, and I did solid. Now let's think about this. This is an or statement. Bring that thought down. This is an or statement. So y is greater than or equal to negative 1, so that's that way. And y is less than or equal to negative 4. So in this case, because it's an or, it has to just meet one or the other of the criteria. We shade it accordingly. All right, we have another squiggly, so we're going to move into some more advanced problems. And our first one looks a little different. And if we think about we want to get the absolute value alone, we do. However, this one's written with absolute value second in the inequality statement. So a lot of times if we're using our thought process and we start reading left to right, 4 is less than the absolute value of 2 plus n, we would think less than. This is an or statement. But remember, we read from absolute value to the number. So absolute value of 2 plus n is actually greater, because it's facing this way, greater than 4. So this is actually an or statement. You can rewrite it so that the absolute value is always on your left side. Make sure you write it accordingly and it's written the same way. And then you'll do your 2 plus n out of your absolute value, greater than 4, or 2 plus n, and we have to this time flip our sign negative 4 because we do the opposite of whatever sign was there. So we had to flip our sign. Then we're going to solve it. When we solve it, we get n is greater than 2 or n is less than negative 6. When we graph, these are open circles. Then we look, because it's an or statement, it just has to do one. So n is greater than 2 goes this way, and n is less than 6 goes this way. So yes, that is a 2-star, but it's more of a tricky way. So now we're going to move on to an 8-star. I want you to see what you can do with this one. Pause and then come back. All right, so if you started with this one, and you got the absolute value alone, and you set up your two inequalities, what you would have noticed is you had to flip your sign. This is an and statement, less than. However, 0 is not a positive nor a negative, so we wouldn't put a negative 0 there. If we did, it wouldn't matter. We would still have a positive 16. So we got both y is less than 2 and y is greater than 2. Remember, this is an and statement. So if I plot my 2 and I say, okay, well, I want to go less than 2 and go greater than 2. Is there any number that can be less than 2 and at the same time be greater than 2? Not that I know of. So this is a no solution. So we cannot have a solution for that one. We would not be able to graph. You could just put a big 0 and a cross for your graphing. All right, this is a 9 star. Notice before you get started that the absolute value is not alone. We have this negative hanging out. So you can almost think about this being a negative 1 out here, and it's being multiplied by this. So we've got to think about getting that alone first. So when you divide or multiply by a negative inequality, it automatically flips your sign. So before we set up anything, we have to get it alone. So we're going to divide both sides by negative 1. Negative 1, we end up with the absolute value of y. And because we divided by a negative, we have to flip this sign. And then we have a 3. Now we can set up our two problems. Read it first, left to right. The absolute value of y is less than, this is an and statement, and then y is less than 3, and y, flip our sign, negative 3. So now when we graph, we have a negative 3 and a 3, open circle. Y is less than 3, this way. Y is greater than negative 3, this way, and this is an and statement, so it's where they overlap. That would be your graphing. All right, our next couple are Mega Mac Daddy stars, 10 star, and then we got D and E. So I want you to pause, try D, and then come back and check. Okay, so let's see if you've gotten this far. So first you want to get the absolute value alone. So we're wanting to get these alone. Right now we have a plus 12, and we have being multiplied by a negative. Remember to do the moving first. Do not try to distribute this negative into here and get rid of the absolute value. This is not how it works. We have to have two inequalities set up, so we have to get it alone first. So we're going to subtract 12 from both sides. We end up with negative absolute value of negative 2 plus x is less than negative 2. Now we're going to divide both sides by negative 1 to get rid of this negative out here. When we do that, we have the absolute value of negative 2 plus x is greater than 2. Now we have the absolute value alone. Now is when we read what type of problem this is. So it's great or, so this is an or statement. Okay, so it has to fit either or criteria. So now let's set up our two inequalities. We'll pull it out of absolute value, leave everything as it is, just with absolute value gone. Or we have everything pulled out of absolute value, flip our sign, and a negative 2. Then we solve. So once we solve for both sides, we get x is greater than 4, or plus 2, x is less than 0. Now let's graph. We have a 0 and we have a 4, open circles. Now these are or statements. X is greater than 4, this way. X is less than 0, this way. It's an or statement, so we can do both. It has to fit either or criteria. All right, your last one, E. To look at this, we have to get this alone again. We have absolute values here, but we have this plus 12. We have to get that away before we can set up our inequalities or even know what type we're setting up. So now let's move this first. So minus 12, we end up with 2 minus y in absolute value and a negative 2. Do not change your sign because you subtracted something. It's only if you divide or multiply by a negative. All right, so now we can read our sign. 2 minus y is less than, so you think, and, but then we have a negative 2. Remember, nothing in absolute value can come out as a negative. So immediately before doing any work, this is a no solution because nothing can equal a negative. All right, final thing, you're going to have a procedure while here. You need to make sure that you have this down. This is one of those things where if you get out of sorts, then it can throw everything off. So the first thing you do is isolate the absolute value first. You want to get everything away from it. Then you're going to look and read it from left to right and find out if it's an and or an or situation. You're going to set up your equations by flipping the inequality or by changing the sign of the second equation. So if you're doing an equation, you know it's just changing the sign. If you're doing inequality, it's changing the sign and symbol the opposite direction. And then you're going to solve for each equation or inequality, graph them, and then you want to check your work and graph and make sure it actually is correct. Remember, your graph is a representation of your solution, so you want to make sure that they match. All right,